Hello, I've had a question in Unit 4, Lesson 6, and this is the second part of the homework, number 41. We have two vertical posts that are 7 meters apart. One post is 4 meters tall, the other post is 3 meters tall. What we want to do is we want to connect the two with a wire that looks like that. Zoom in a little bit here. And I'm going to call the lengths L1 and L2 because that's what we want to optimize. So our optimization equation, we're going to optimize length. So length equals L1 plus L2. So in order to do this, we need to figure out what are the respective L1s and L2s. So what I'm going to do is I'm going to let this length here be X, which means the remaining length on the other side will be 7 minus x. So for L1, we know that L1 squared will equal 4 squared plus x squared, or L1 equals 16 plus x squared to the 1/2. So there is my first constraint equation. So that's what we're looking for on this side is our constraints. Next, our L2 squared is equal to 3 squared plus, and then in brackets, whatever's left over. So the 7 minus x squared, or L2 equals 9 plus bracket 7 minus x squared to the 1/2. So there's our second constraint equation. And now what we can do is we can enter those in to our optimization equation, which would mean that the length is equal to bracket 16 plus the x squared to the 1/2 plus the second length is 9 plus 7 minus x squared to the 1/2. Now we can determine or optimize it by taking the derivative of dl with respect to dx. So we end up with 1/2 16 plus x squared to the negative 1/2. And then the derivative using the chain rule inside is 2x plus 1/2 bracket 9 plus 7 minus x squared to the negative 1/2 as well. And then taking the derivative inside, move over a little bit more space, we end up with the 9 goes to 0, 2 bracket 7 minus x to the exponent 1 multiplied by the derivative inside that is negative 1, so using our chain rule. So that being said, we can clear this up a little bit. So I know that this particular 1/2 and that 2 will cancel on that side, that 1/2 and that 2 will cancel. So now we can let dl by dx equal 0 to optimize, and I'm going to return it to its square root notation just so it's easier for me to kind of work with now. So if you'll agree with me here, x over the square root of 16 plus x squared, and then the other side will be minus on top 7 minus x, square root of 9 plus the 7 minus x squared. Alright, so now we just need to go ahead and solve this, and this is where, if you're going to run into troubles, probably here because of the algebra. So I'm going to move this term to the other side, and I'm going to cross multiply. So we end up with the 7 minus x multiplying with root 16 plus x squared. And on the other side, we have just the x term, and it's going to be multiplying with 9 plus 7 minus the x squared. We need to get rid of those radicals. So the process we do is we square both sides. Unfortunately, what that results in is 7 minus x squared multiplied by 16 plus x squared. The other side's x squared multiplied by 9 plus 7 minus x squared. So this becomes a bit of an algebra challenge here in your expansion. So 7 minus x squared, we get 49 minus 14x plus x squared multiplying the 16 plus x squared. On the other side we have x squared, and inside that bracket we're going to have 9 plus 49 minus 14x plus x squared. So when it's all said and done, we end up with 784 on this side plus 49 x squared. So now I'm just doing the distributive law again. Minus 224x minus 14x cubed plus 16x squared plus x to the fourth equals, now go on the other side, so you can see it's quite a mess to keep track of, 9x squared plus 49x squared minus 14x cubed plus x to the fourth. So now I'm going to bring everything to the same side, and we see that the x to the fourths will end up canceling. We see that the 49x squareds will cancel. We see that the 14x cubes will cancel once it's brought over. So all I'm left with really is that 9x squared to bring across. So just moving around here, I end up with 7x squared minus 224x plus 784 equals 0. Everything's divisible by 7, which makes that really nice to work with, or a little bit better to work with. And this also factors to x minus 4 and x minus 28. So that would tell me that my final answer would be 4 and 28. Now, that 28 is inadmissible. And the reason for that is it's too long. Alright, if we go back up to my picture there, we see that if x is 28, then we're going to exceed that value of 7, so that makes no sense at all. Alright, so that means that the only valid answer is the 4. So, just move up here. So therefore, x equals 4. So my final diagram would look as it would above, but we need to find out our lengths. So I need to substitute in my two lengths. So L1 is going to be, I just need to move it down so I can see it. So L1 is going to be bracket 16 plus 4 squared to the 1/2, which means that that is the square root of 32, which means that that is 4 root 2 when you reduce it to lowest terms. Then, if we do the same for the other, so if I find L2, and the formula for L2 was 9 plus bracket 7 minus x squared to the 1/2, that becomes 9 plus 3 squared to the 1/2, which means we have root 18, which would be 3 root 2. So total length then is 4 root 2 plus 3 root 2, which gives us 7 root 2 meters or units. All right, so there we go. There is how you would work through question 41. The setup, it's probably most people on the right track for the setup, but yeah, that algebra gets pretty ugly and difficult to deal with. So if it's the algebra that you have the trouble with, I'm not too worried because I'm going to follow through. All right. If you have any questions, let me know and I'll try to clear them up.